introduction, and thank you all for coming and braving the cold. I've been told that even by Madison standards this is cold, so honored that you're here. And when I got the invitation from Dominique to come, I was honored to talk. I like to talk, and I like to talk about this subject. But then the question becomes, well, what should I talk about? And Dominique sort of said, well, I think there's a wide range of topics that people would find interesting. And I think that's really important because, and I found in that a kindred spirit, in that this is an exciting time for science communication. There's a lot of opportunity, there's certainly a lot of need, but also we need to be unencumbered by conventional wisdoms. We need to be unencumbered by how things have been done. We need to be unencumbered by static talking points. We just need to be thinking freshly about this. And so in the conversations that we have, we need to go in with sort of a mindset that a lot of things are interesting, that a lot of things should be tried, that a lot of things should be considered. So today I'm going to talk about something that is really dear to where I am now, and especially where I hope to go, which is science filmmaking. When I say filmmaking, that's sort of a broad, nebulous term. I really sort of mean mostly sort of independent filmmaking, the idea that we're at sort of feature-length documentaries and documentary series. We'll get into a little bit about science television, and that sort of skirts the line. There's definitions are blurry, but that's sort of what I'm talking about filmmaking. Now, when talking about science filmmaking, I think it's important to start with some caveats about myself. One is I am not a scientist, and so that's one thing. I'm sort of trying to communicate science, but not coming from a tradition of studying science or getting a degree in science, even undergraduate. On the other point, which I think might be more maybe surprising, is until recently I didn't even consider myself a filmmaker. I considered myself a journalist, a video journalist primarily, as we've heard that I worked at CBS News for a long time and worked on news magazine, cable programs. And this distinction between science journalism and science filmmaking is something we'll also explore a little today, and why I think filmmaking is so important and why I think I am where I am. So to get a sense of what brought me here, I think it's good to sort of get a sense of where I came from. So while I didn't study science, I actually was born into a family of science. My father is a scientist. My mother was a math teacher at various levels. And so science was part of my childhood. I spent time visiting my dad in his lab, and we had lab parties at our house. And so the whole culture of science was something that was very normal to me. That's sort of where I grew up. The idea of, I knew what grad students were and what postdocs were. I sort of saw the stress that came with writing grants or the training purposes and complaints about university administrations and all that kind of stuff that you hear. Sort of the culture of science was something that was just part of my childhood and part of my upbringing. And as a result, I think that sort of like a language that you learn at a young age and you might forget the words, but that sort of cultural reservoir remains that you can call upon. That's something I think that's just part of who I am that I've taken forward with me. I studied American history and literature in college, and I thought I wanted to do historical documentaries. This was sort of the age of sort of Ken Burns coming out, and this was sort of exciting stuff. And I knew I didn't want to do academics. This is my own personal bias. I felt I had too restless a mind. I couldn't focus too much on any one topic, and so I thought, well, filmmaking is something I could go sort of sporadically from topic to topic and try a lot of things. That even proved to be a little too ominous and scary. I said, well, journalism is even more constricted. I can spend less time on more things, so that sort of seemed to be something I wanted to do. So I ended up going into journalism. And when I did that, I realized something I guess I already knew intuitively, that I worked in very general, CBS News, a very general, broad news organization, responsible for covering the world, really, in all its forms. Although, by the time I got there, it's shrunk from its glory and has since shrunk much further. That's topics for whole other types of conversations about the media landscape. Nevertheless, I was still a big place with big goals. And I got to see that when I started covering the world, I started seeing science everywhere. Now, sometimes these stories were considered economic stories. Sometimes these stories were considered political stories, certainly environmental stories, technological stories, medical stories, of course. But science, just if you sort of see the world from science, and you sort of look at the headlines in the newspaper, you think, well, you know, this weapon system, well, that has a scientific angle. Or how we're dealing with the confusion over this data, that has a scientific angle. So I started sort of covering the world and seeing science everywhere. At the same time, I saw something else that was more troubling, is that my peers had almost no background in science. They didn't understand science. Now, I can't think of any that had a degree in science, but of course that included me too. And I have my own weaknesses and biases and my own need to learn about science. But more important than the facts of science, and if we be honest with ourselves, like science is so big and so diverse, like you could be the world's leading expert in something and still have trouble understanding a topic that's close to your discipline, let alone a physicist understanding a microbiologist or whatever. So I think it's not a right standard to expect that science journalists really understand any particular story that they're doing at a detailed level. But I also noticed that they didn't understand just how science works. The idea of data and confusions of data, bias, collaborations, competition, and how that manifests itself in the way science is done. The questions about how we train scientists, how we fund science, how science works in different countries, or how it's unified, how different disciplines, how funding priorities direct research and publishing, and all these things that I'm sure you guys all know and take for granted. That cultural world, I think, is missing from a lot of the people who are charged with at least telling science stories to the general public. And on top of that, sometimes this takes some really comical turns. I'll share with you an anecdote. Several years ago, a decision was made for, I think, on dubious scientific data, to change the beginning of daylight savings time. There's talk of energy efficiencies, and there was talk about, I don't know, other things like that, but efficiencies of time and all of that. And I was tasked with telling that story. I was like producer of the CBS Evening News. Not a big, important story, but a sort of fun story. I was working with a correspondent. We started gathering, people talk about time zones and talk about how we measure time and the sun and sort of interesting things, and do some interviews, and this was going to be a short piece. And the goal of the Evening News is worst thing you can do is miss air, which you never do at all, but the closer you get to a deadline, it's going to, the deadline starts when the show goes on the air. You better have your piece finished well before that. So we were sort of in good shape, and I get a call from what was known as the Fishbowl. The Fishbowl is called the Fishbowl because in the old CBS News, the big studio where the anchor desks were and all the national and foreign desks, there was a office enclosed in glass where the senior staff resided and where the edicts would come down about what you would cover and everything. And so I was in the bowels of the edit room. We get a call down, and I get a call, and the woman on the other line who was in charge of this story said, "Well, Elliot, how's it going?" I said, "Okay, we're going to be fine." And she said, "Well, do you have images of birds in your piece?" I don't know if you've had an experience where you get a call from a boss and you just don't know how to respond. Like, where could this go? I'm almost afraid of the answer. But here we were. I was like, okay. I was like, my mind started jumping. Like, what could you possibly mean? Is it maybe the shadow that we're going to see, the different shadows? I didn't know where to begin. And I said, okay, well, what do you mean? She's like, well, I know you're focused on humans, but the birds are going to be confused too by the change of time. So, I didn't really know what to do with that. And it's sort of the same thing. It takes like a little bit to process, and you're like, oh my gosh. But there's just so much there that's just not understanding. And I want to be clear that these people, a lot of people, they're not stupid people. They're not ill-informed. They could tell you the intricacies of the media peace process or the parliamentary rules of the Senate often. People know stuff, but science is somehow this unknown. And how do we address that? How do we change this? How do we communicate this better? So I think it's important to step back and look at a system, I think, of how I envision this. You sort of have, on the one hand, the world of science in all its complexity and confusion, and just how much is being done, this just spout of energy and change, and all the questions that we learn about that makes this a very complex sort of endeavor, global and all of that. And then you have the general public, which of course, also includes the scientific community, but for the purposes here, we'll sort of consider these two different orbs. And the question is, how do we transmit the information from the scientific community, this global writ large, to the general public? Now, there are all these sorts of different ways, obviously, and I'm going to focus, on mostly a certain way, science filmmaking, but as we whittle it down, it's important to sort of consider briefly some of the others. One primary means, which obviously is a topic of a lot of contention and discussion and debate, is formal education. That's where a lot of people learn about science is in school, whether that's achieving the goals of inspiring people into science or how we teach it. Obviously, that's a whole other many considerations. There are some direct appeals to science in courts of law. There's some in terms of policy debates that sort of goes through. Scientists testify, less and less maybe, or more and more contentiously. But then there are few people who communicate directly from the scientific community to the general public, and whether they're scientists or how they fit. I mean, if you probably were to ask people to name two scientists that speak to the general public, they would probably say Bill Nye and Neil deGrasse Tyson. Problematic in their own ways, potentially, and we could I'm not going to dig down to there, but there you have it. I mean, there are, at a lower level, there are people that give TED Talks, that lecture series. These are well attended, these are important, they're podcasts. So there's a lot of means by which scientists do communicate directly with the public, but it's really pretty niche, and it's really pretty small in terms of the overall amount of information that the general public is learning from science. And I think it's important to consider in that way, it's very different from other endeavors. So if you sort of consider, again, the world of science and the world of the general public, and there's sort of a pipe, pretty narrow, and to stretch the metaphor with a lot of filters, that takes the raw knowledge of science and translates it into the words and images and sounds that is consumed by the general public. And if you consider other endeavors that people deal with, let's say sports, for example. People read about sports, they listen to maybe talk radio, but they're also experiencing it directly in large part. Music, films, people might read reviews. Politicians, that's also, speak directly oftentimes, they give speeches. Corporations speak directly oftentimes through commercials. But science, by and large, I would maintain, is mostly processed. And is processed by a whole group of different individuals. It's processed by TV news producers, by book editors, by newspaper editors, by PR departments, both the corporate level, university level, that sort of say, okay, like how do we take what the scientists are saying? Because very few people will read the original papers in the general public, and then there's there's different filters where there's a professional science press that often then helps filter it for a general press. But by and large, it's passing through this pipe of, and in these filters, I think there's certain topics that pass through more readily. I think astronomy does pretty well. I think dinosaurs do well. I think evolution does well in some degree. Nature, which can be both considered scientific, but also sort of beauty, and those go through. Protein synthesis, not so much. Dark matter, maybe not so much. So there's these filters, and I stand before you as somebody who's been a filter, am a filter. I mean, that's the way it's going to be. I mean, again, the ability of the general public to understand the raw science is just never going to happen. So there's going to happen. This is by necessity. The question, I think, if you want to improve science communication, though, is we have to hone in on this pipe that's connecting it. I think there are very worthwhile endeavors to improve science communication from the point of view of the scientists, to train scientists to talk better, be able to share it. And I think that's all worthwhile. I think that it should be considered, how we review such things as compensation and tenure and the responsibility of science in their research to transmit it or to sort of share it with the public. I think that's all important. But I also feel we got to remember that the goal, what we want of our scientists is to do research. And that we should consider communication a benefit and important and something that should be encouraged. But I think that to put the burden there as what the fix is misplaced. It's worthwhile but woefully insufficient. You could also talk about the general public. It would be great if they loved science more, if they were interested in science more. And that's true too, but I think that that's sort of its own feedback loop, because the more inspired they are, the more interested they will seem in it. So, and the general public, I mean, people have complicated lives. I mean, it's to put the burden on the public, demanding science or all of that, and it's not clear to me, again, if we go back to challenging our conventional wisdoms, that they aren't demanding more than they're given, and we can get into that. But I mean, the burden can't be on the general public either. I think the burden is on the communicators, and that the communicators need to be working with the sort of the spout that puts it into the general public, the distributors and those kind of things, and the scientists. So I think that there are roles for everybody, but if we're going to improve science communication, it's going to be about fixing this pipe and addressing these filters. So that leads, I want to also contend that there are I think there's a lot of hopeful signs in science communication. I think there's really good writing, print science communication. I think that there's been exploiting podcasting in that form has been a wonderful means. I mean, people love Radiolab, but there's so many more that are dealing with scientific topics. And that should all be encouraged, and I think it can be. And I think we're seeing that the marketplace is rewarding that in many ways, that the popularity of a lot of the science content is being affirmed. But now we're getting to video, and primarily documentary film. And the scale of that is it's at a scale that is just, the barriers of entry to that are significant, in that the cost to do film dwarfs the cost to do print, even in audio. And that if you really want to take full advantage of what cinema, we'll get into it, but it can offer, you need to spend even more money. It's a matter of how we film things, what the graphics are, how much time we're taking with production. The budget allows for you to make mistakes and try different things to get at it, to get at communicating something better. So it's a difficult endeavor. But yet at the same time, I want to emphasize that we're also if you talk to the film community outside of the science filmmaking, it's actually a really exciting time. There are new Netflix and HBO, and international outlets. There's been an explosion in the quality of independent documentary filmmaking. And if you go to film festivals, you just see it. And they all will tell you, the quality of the films increases, the number of submissions are increasing, the audience is increasing. And there's many, both in theatrically and otherwise. But if you go to these film festivals, you will see no science. It just doesn't exist. Before I go on, let me ask a question. You guys are all interested in science. How many of you have watched a science documentary in the last week? Last week. This is good. That's a lot. How about the last month? A few more. Last 6 months? Last year? About the same number. Still not, considering how interested you are, considering how much content you're consuming, it's just the amount of ability to watch this is rather limited. And if you go to the film festivals, you'll see, being independent film is sort of like academics in a way. It's a hard life. It's not a lot of financial reward. It's a lot of training and struggle. It's a lot of scurrying for funding. And just like in academics, where often research tracks to funding and opportunity, so does documentary film. And there is a market for certain forms of documentary: social action, environmental, nature, political. And so you see that overwhelms the number of submissions and the funding and this feedback loop and the sale, and all of that happens around these forms. And science is really considered a niche that's often relegated to television, that's often in some very mature sort of systems like Nova. There's been a lot, and cable networks like Nat Geo and Discovery have really fled this, that they used to do a lot more. They're now doing a lot more reality programming, like Ice Road Truckers and things like that. So there really isn't a funding mechanism, and as a result, the most creative people are not going into, I mean, there's just not a lot of opportunity. And not just directors, but editors and storytellers and graphics people and promoters. And then the distributors. A lot of distributors have the same sort of, I think, blind spot that the news reporters have, that they just don't understand it and they don't see a market and there's nothing for them to compare it to. Well, how is this film going to be do vis-a-vis this one? There's just no means of comparison. And so as a result, there's just not a lot of filmmaking being done in science. And I think it's a real shame because film is an incredible mechanism for communication, and that's been proven. And especially, you know, when you add in all of the elements of production that you can bring to bear, like graphics or like cinematography, and the editing process, which I think allows scientists to tell their own stories, especially if they're working with the filmmakers in a collaborative environment. So that you're not, and this is one of my other pet peeves about the way science is often portrayed. Even in podcasts and places where it's doing better, you often have a sense that the scientist is allowed to sort of speak a little jargon, and then there's a translation. Somebody, a host, comes in, well, what they're really saying in English, haha, is this, or this is what you really need to focus on, or we let them give their spiel, and now we're going to sort of focus it, we're going to propel the story. And that itself has its own negative feedback. It sort of suggests that scientists are a separate species, that they can't speak directly. But again, through what's interesting about one of the real trends in documentary filmmaking is to remove narration from it. That's really considered the standard now, largely, is that heavily narrated documentaries are a little out of vogue. And so if you take that same sensibilities and you say, well, we're going to direct that to science, you suddenly have scientists speaking directly. Although in an edited form, trust me, you wouldn't want to sit through any of these raw interviews. But that's part of the point. That doesn't mean that that people can't speak directly. And that what the public is now to hear, with science stories told in this way, I'm going to show some examples, are scientists speaking directly to the public, and what that entails, and what that would mean for how scientists are then perceived by the public and the stereotypes that might exist. You know, and another thing that's really important with independent documentary film these days is that there's a sense that diversity needs to be expanded, that the diverse voices need to be included in our narratives, and that the people producing these narratives also must be diverse. And so what that allows too is that these sensibilities, again, could be brought into science, you know, where there's a diversity issue not only in who's doing it, but even, I think, even more, especially is even the disconnect between who's doing it and even how it's portrayed then to the public. So if we can bring all this idea of filmmaking and sort of the trends of filmmaking now to science, what can we accomplish? And so that's sort of where I am, what I hope to do. And I think that when we think of it, though, we also need to be on guard about certain tropes of science storytelling that are also of filmmaking. So films like to have a hero, and I think there's a sense that science is conducted by lone heroes. Very big misconception, obviously, but that one that can easily feed into narrative. Film also likes the iconoclast, railing against the system. Often iconoclasts in science, while important to consider. You'll see this with climate change, for example, where there's an overwhelming consensus. So how that storytelling manifests itself on film, you know, there's a question of competition, of a ticking clock. This is how often science is done, two people, you know, egos and driving, as opposed to sort of, again, representing what I would say the system of science and collaborations and building upon other people's knowledge. So I think that as we enter this space, we need to be aware of certain pitfalls and certain considerations, but all that's addressable. So what I think we need is, first of all, I mean, obviously, like everybody, funding, but funding that's directed towards experimentation. That I think to do carbon copies of what's worked even is fine, but the marketplace is doing a lot of that. And so I think that if we are going to get an injection of funding, it has to be with the explicit idea of challenging assumptions, with the understanding that we might fail, that we might go too far in a certain direction, that the end product might not do as well as we hoped. But again, and I think the costs that exist with filmmaking make this, everyone wants, if you invest in a film, you want it to be a success. And so how can you build in experimentation into this structure of science filmmaking? And then, more specifically, how do we work together to do this? I mean, this idea of, with the understanding that filmmakers will have their own blind spots to science, and scientists will have their own blind spots to communication. Can we build a collaboration? Can we make these worlds come together in a way, and then with also a knowledge of how we're measuring its impact on the public, with impressing upon distributors about why this is important, with finding alternate avenues for distribution, for raising awareness, for proving that there's a marketplace for this. So I think it has to be all encompassing, but the center has to be on filmmakers working with scientists, I think, and then ultimately general public. So that's sort of, I think, where we are. And I'm going to play us some clips here, which I will sort of deconstruct a little bit. One clip from the first clip is going to be from a series of 3 short films that was an experiment that we got funding from the Simons Foundation, generously. And the idea was to pick a very mundane topic and approach it from 3 radically different short film approaches. So we picked diabetes. Seems like a lot's been done and everything, and we did it from 3 very different angles. We did one by looking at the sort of South Asian phenotype and the mystery about why in India people with very much lower BMIs get type 2 diabetes than in the West, and sort of the struggle to understand that, and diving in through that clue into questions of epigenetics and things like that. So that was one. We did one where we went right at the hero complex of science. We looked at the discovery of insulin in Canada, and it's sort of a mythology that emerged from these 2 people, Benton and Best, working supposedly to get it alone, but really showing that it was an iterative process building on other breakthroughs and sort of how that worked. The third one, which I think was sort of the most audacious in its experimentation, was really to go straight at the science. We're going to tell a straight science story. We're going to do a short film on metabolism. We're trying to explain what metabolism is. We're going to try to break it down. And so when we went in there and trying this new model of working with scientists, we sat down with leading scientists in the field and we started like, how are we going to tell this story? How can we do this? And it's amazing what we saw was that the same instincts that we've all heard about kicked in, the same conventional wisdom. It's like, okay, well, what's the metaphor? Everybody instantly jumped for a metaphor. And we got this, well, it's sort of like a banking system. I don't remember, like glucose is sort of the common currency, and I know that the liver became the Federal Reserve Bank, or I don't know what it was, but it was like this, I'm like, whoa, I'm like, where are we gonna go with this? And I'm drawing little, Brinks trucks on the whiteboard or whatever. Anyway, it didn't make any sense. And so we started to, what's really going on? So, well, we're burning fat. What's burning? Yeah, well, it's really sort of, if you look at the Krebs cycle, it's like sort of controlled burn. That's what it really is. If you look at it chemically, that's what's happening with how the body is processing its energy. And we said, well, okay, well, let's go with the Krebs cycle. We're going to put the Krebs cycle on our film. We're not going to shy away from that. We're going to and try to explain this in a way that appeals to the public, and also see whether we could do it. One of the big questions is, well, who's your audience? Can we do a film though that reaches a lot of audiences with one film? It's sort of like you think about it. People watch a football game on Sunday, and it's not like they do a different football game for the people who play high school football, and a different football game for the people that don't know much. And it also doesn't mean that you have to start from scratch each time. So, well, there's 4 downs. I mean, I think that's sort of how we do science. It's like everything. What's a protein? What's DNA? It's like people don't bring any knowledge. So we thought we would try to push right through that and do an experimentation. So I'm going to play a short clip from that film, which is entitled A Brief History of Fat.
Fat is composed of, a glycerol with 3 fatty acid chains that come off of it. And those fatty acid chains, our bodies are beautifully able to cleave them, bit by bit, and we burn them. And so a little bit of fat produces vast amounts of energy.
I mean, fat does burn. If you take a piece of fat that you cut off a lamb chop and you put a match to it and you light it, fat burns. whale oil was used as a source of light and heat. That's just melted fat from the whale. They're chunks of a fat molecule that are identical to chunks of a gasoline molecule. They're just long carbon chains that are full of high energy electrons. Now, if you simply liberated the fat in your body by literally burning it, obviously would generate a lot of heat, which would damage your body. So really what your body has learned to do is extract the energy slowly so that it doesn't cause destruction.
We take off 2 carbons at a time, and we throw those carbons into what's called the Krebs cycle.
By running it through a series of chemical reactions, it allows the energy to come out in small bursts in a way that can be captured. But from a physical chemistry point of view, it's really very similar to burning. You start with a hunk of fat, you end up with carbon dioxide and water, and the energy has been released.
So that's, we actually ended up distributing this through Slate magazine, and they shared the video, and this video itself has 1.5 million views, almost, on YouTube. And what we found was that in our test audiences, some people just got, wow, I sort of see that there's a dance of chemicals. Some people said, wow, you know, they're a biochemist and they studied the Krebs cycle and never quite experienced it this way before. So again, I mean, it was an early experiment, but I think we saw it's got a really positive response. No metaphors, a lot of use of graphics, and it came out of a discussion and a knowledge base that only could have come through collaboration with the scientists before we start. I mean, I think that's another thing, is that oftentimes the way films are done too is that you sort of, the filmmaker will sort of come up with an outline and build it all, almost like they're growing a tree and they planted it and they know where it wants to grow, and they sort of hang scientists on the end, sort of like Christmas ornaments, just to make it look good. But the essence of what the storyline was not done through a series of discussions with scientists about what they find. It can't only be one source, right? You have to talk to many different people and push them and pull them. So that's what led to this particular film, this particular part of this particular film, and the entire film itself, which, as I said, is about 22 minutes of discussions of metabolism. Now, in recent years, as Tommy mentioned, I moved out, I was in New York, moved out to San Francisco as part of this iBiology, which has been around for nearly a decade. It was really mostly done for producing science content for professional science audiences, and we're trying to push it into a general audience. And we're developing something to be launched soon called the Wonder Collaborative, which is our brand and effort for how we're going to collaborate to tell these kinds of stories. And our first product of this, our big test product, has been going on for a couple of years. It's been complicated and interesting. Is a story about gene editing and CRISPR. And I'm going to play for you, it hasn't been released yet, but I'm going to play for you. You'll be one of the first people to see the trailer for that. It's called Human Nature. And I would talk a little about how this came in One More Project. And then
Mother Nature gave us something that's richer than our imagination.
We saw a very peculiar pattern.
Never seen anything like this before.
I remember him saying, remember this word, CRISPR.
You can actually use CRISPR to change DNA.
David's doctor told me, just hold on, there's something coming.
We've never had the ability to change the fundamental chemical nature of who we are, and now we do. And what do we do with that?
Our pig is the most advanced genome-modified animal running on the Earth.
My lab has been accused of taking science fiction and turning it into science fact. I consider that very high praise.
We could engineer a single gene that could potentially make us all more muscular. But should we make that universally available?
Many people find what we're doing to be disturbing or they're not ready for it.
Что человек может создавать человека, человек, который может воевать без страха и без боли. И вот то, о чем я сейчас сказал, может быть страшнее ядерной бомбы.
Should we really be manipulating the heredity of future generations given our lack of knowledge about so many things?
I don't know where you draw the line between not having albinism and deciding your kid needs to be an extra foot taller so they can be a good oarsman and go to Yale. Where is that line? Who's going to draw that?
Anything that will stop my child from suffering, I'm for.
You know, draw this ethical line wherever you want, but don't draw it in front of my disease.
Humans are very good at inventing things, but they're very, very bad at working out what the implications are.
The balance of nature is built of a series of interrelationships between living things and between living things and their environment.
Often you don't realize that you're in the middle of a revolution until after the revolution has occurred.
So for this one, this hasn't been released yet, and what I want to talk about for this one again is this came out of constant collaborations with the scientific community throughout the process. And one thing I want to highlight here for this trailer and the way we're promoting this film and what the film entails is you will notice the number of voices that are in it. It's not one person's story, and how different we're going. So the idea is how do you tell the story of science that's complex in a way that's novel? And it makes it more, trust me, it's a lot more complicated to try to piece these little parts together, and we have so many different voices. Then sort of, here's a hero narrative, here's an inventor, here's a patient we're going to follow. All those were considered, but we felt, again, to capture the essence of science, you had to capture all of its complexity. And you see as well, leading with the science. Starting with the science, talking about the code, talking about how this is used. We really tried to push beyond the level of science that you normally get. In some ways, in that part, it's very similar to the part you saw about metabolism, but then we have the overarching ethical considerations as well. But these discussions came from the scientific community, and that we have the scientists themselves talking about their uncertainty. No narration, and our hope is that it humanizes this debate by saying, people are struggling. Scientists are no different. They're wondering, and they're disagreeing themselves. There's no monolithic idea of where you draw the line between how we're going to use these technologies. And so to capture that in film, I think, is an incredibly powerful way. And again, no narration, hearing the scientists talk directly to the viewer. We shot it so they're actually speaking into the camera, so that you're seeing this, making this connection directly. And so before I go and take this, I wanted to just show another quick, from a very different film, which I was a producer on. I don't know, has anybody seen the film The Most Unknown? Oh, cool. So we're gonna see the trailer for this. I was a producer on this film, a different director from the Human Nature, very talented director, and a very different goal in how we're going to tell science. So I'm going to play first, and then we'll talk about it, and then we'll go right into questions.
How can I, as a small person, answer a question about the cosmos? You have a puzzle with a billion pieces, and we've got one piece.
So, why are we here?
The microbes that I study in hot springs are paramount to understanding where life could be in space.
You're trying to solve this problem. I wake up at night thinking about it.
So you're a nerd too?
100% nerd.
We can speak from very different scientific disciplines and yet speak common language.
Oh my God!
Oh my
God! Welcome.
See if you can make a robotic hand move by your thoughts.
When you're right on the edge of this big unknown, it's very hard to say where the science is going to go next.
There must be things we cannot understand.
What makes you willing to search after something that we don't even really know
must be
exists?
there. Come on.
Where do you get that, though?
Everybody's dream as a scientist is to make a big discovery, to truly advance the field. It's a quest for knowledge, it's a quest for understanding.
Dark matter, dark energy, there's something beyond, and we don't know yet what that is.
This is a tool to explore the center of the galaxy, essentially.
I think the important questions transcend beyond one laboratory.
We scientists are trying to discover the story of truth, like what's really out there.
Here, so we have no idea.
We have no idea.
Okay.
So, a very different film. That basically we brought scientists from very different disciplines together to explain their research. The biggest criticism we got from the film, which we took as a compliment, is that people wanted to know more science, which I think is its own clue. It was an experiment in that once we settled on this scheme, it all was planned out. You couldn't, what we do with a lot of films, like cut someone out because it doesn't work, because it would have broken the chain. So we were trapped a little bit, and we had sort of unnecessary other constraints. But nonetheless, this was about how does science work, and that the idea that whatever divides scientists from their knowledge base, first of all, they are as much, they have to learn as much as mostly the general public when they get into a field that's very different from theirs. But they share a common instinct, they common drive, they share a common goal of pushing beyond the horizon. And so, finally, before we go to questions, I think that that's one of the really important ideas, that if you think about how science is often taught and often also portrayed, it's looking backwards. It's taking the moment that we are now as if that's the peak and looking at the ascent and how we got there. And if you go to talk to actual scientists, you go to meetings, they're really concerned about where they're going. They look up and they're like, okay, we're on a ledge here, but we don't even know, we can't even see the peak, it's somewhere in the clouds. And when we get there, we realize it's just another ledge and we have further to go. And so how do we capture that? And how do we change the dynamic of filmmaking so that it's not retrospective, so it doesn't fall into these traps, but really encourages the transmission of science and communication of science. And so finally, I really do think that that has to be a collaboration. It has to be with people like you, and I know you come from many different disciplines, that this brings you here together. We've seen how interdisciplinary science has really propelled many, many fields. It's not uncommon now to see mathematicians and biologists and computer scientists collaborating and working together. Those divisions have been broken down, and I think it's really important to break down these divisions between the science communicators and especially my plea to the filmmakers and the scientific community. So that's, obviously talk about many more things, but maybe, I'm curious to hear what you guys are interested in and think about.
Thank you, Elliot.